Okay guys, today you're going to be watching a video on our Unit 1 test review. Now you're working on the reviewing class, and what I'd like for you to do is to work a few problems, come back, watch the video for that portion. You're going to get more out of the video if you work the problems ahead and then come back and watch me work them so that you can check, did you do it correctly? Okay, so I need for you to remember that as you go through. I'm just going to kind of work them. You pause the video as you need to. Now, this is your review for your test tomorrow, so whatever is not finished in class, you should get done, but if you don't, you need to take it home with you and finish. I will take this packet from you tomorrow before you take your test. Okay, so this is supposed to help you study, so make the most of it tonight. But you will benefit more from this if you work ahead. So pause the video once in a while, work ahead, and then come back to see how you did. All right, so the beginning section is talking about the real number system. And you're just supposed to fill in the titles of our graphic organizer. So this is just like the one we had in our journal. We said that every number we know at this moment is somewhere on this chart. So we said the title would be the real number system. So that's all we're looking for up here. Okay. And then we said, okay, our chart is really divided into two sections. We've got everything here on the left, and then we've got the numbers that are going to be on the right. So let's start with the left side. We said the very first numbers you learned about were your natural numbers. Those were your counting numbers, like 1, 2, 3. It's how we naturally count. And then we said we added to that whole numbers. This is where 0 came in. This is natural numbers and 0. So like 0, 1, 2, 3, and so on. And then negatives came in. So we said that's integers, which are whole numbers and their opposites. So no decimals, no fractions. We're still just looking at whole numbers and their opposites. Okay. And then finally we pulled in fractions and decimals, and we said those were rational numbers. We said that is any number that can be written as a fraction. Okay. So that's your terminating or repeating decimals. So that might be where we see, and I'm just going to fill it in down here for you to have some examples, like 2/3, maybe 3/10, maybe 1 2/8. Maybe we've got 4/10 repeating. Okay, all of those are rational. I can write them as a fraction. And then over here by themselves, separated, we had irrational numbers. So we said that's the numbers that cannot be written as a fraction. So they are non-repeating, non-terminating decimals. We said pi was a good example. We might see the square root of 2. We said the square root of any non-perfect square, that would be irrational. If we had, let's say, 2.135 ... those dots mean that it's going on forever and ever. Okay. All right, now let's look at the questions. It says, how are natural and whole numbers different? So the only difference between natural and whole numbers is the 0. So 0 is a whole number, but not a natural. That's the only difference. All right, number 8 said, how are integers and rational numbers the same? All right, so how are integers and rational numbers the same? They both can be written as a fraction. -2 is an integer. -2/1 is still an integer. It's also rational. Okay. All right, number 9. Can a number be both rational and irrational? No. Remember, we said this is the dividing line. They either are on the left side of the chart or they are on the right side. They do not overlap. Number 10. Are all negative numbers integers? No. An example could be -2.5. It's negative, but it's rational. Okay, so be careful. That's a tricky one. All right, and then you had the box. You needed to put the numbers in the right box. Let me make this a little bigger for you. So you had a lot to sort. And we narrowed it down to just rational or irrational. So do these numbers belong on the left side of the chart or the right side of the chart? I hope that you have filled the numbers into the chart before you watch me do it. It's going to help you more if you think through it. All right, pi/4, that is irrational. Pi is irrational. The square root of 16 is really 4, and 4 is rational. So the square root of 16. 33/100 terminates, so that is rational. We have just pi itself. That is irrational. We have 0.12548 ... We said those meant that the number keeps going, it's not repeating, so it is irrational. 2/3, that's a fraction, so you bet that's a rational number. 0.621 repeating, we said repeating is rational. The square root of 8, that's a non-perfect square, so that is irrational. All right, we haven't really talked about that, so we're not going to place that in rational or irrational. We're not going to include that at all. All right, and then we've got 1 5/10. That is a rational number. Okay, so hopefully you got those right. All right, let's move on to the next page. Be sure you are working ahead. All right, the next page is true or false. Number 12 says -5 is a rational number. Can I write it as a fraction? Yes, so that is true. 0 is an integer. What are integers? They're whole numbers and they're opposites, so true. Number 14, the square root of 16 is a natural number. The square root of 16 is 4, and 4 is a natural number, so true. All right, 15, -3 and 25/100 repeating is an integer? No. Remember, integers are whole numbers and they're opposites. All right, we've got the square root of 8 is a rational number. Well, if I remember, we just put the square root of 8 in the irrational box because it's not a perfect square, so false. Oh, and let me back up. On 15, I put in because I said no, but we know that means false, so false there, or no. All right, then 17, it says whole numbers contain 0. Yes, so that is true. All right, number 18, the square root of 7 is a real number? True. It is on our chart. It's irrational, but that is still a real number, so true. All right, 19, -2/3 is an integer? That is false. Integers cannot be fractions. They are whole numbers and they're opposites. Number 20, 18 is a whole number? True. Square root of 3 is an irrational number. The square root of 3 is not a perfect square, so that is true. All right, 22, -121 is a whole number. False. Negative numbers are not whole numbers. 5 7/10 repeated is a rational number. True. Rational numbers can be repeating. All right, 24. All irrational numbers are real numbers. True, they're on the chart. That is part of the real number system. All right, 25. 2.435621 ... is a rational number. False. That is irrational. It keeps going. All right, and 26. 4/5 is a rational number. True, because 4/5 is a fraction. Any number that can be written as a fraction is a rational number. And number 27, 6.57 is a whole number. False. Obviously, it has a decimal, so it is a rational number. Okay. All right, next page. Now we got to do a little more math than just thinking through. All right, number 1 says the circumference of Earth's moon is about, and we got, looks like 1,091,500,000 billion. Yep. So we've got to put that in scientific notation. So think about, where's the decimal now? Where does it need to end up? And now remember, when you're doing this page, you should have worked ahead, and then you're coming back to watch the video when you have answers to look at. All right, so I'm moving the decimal from here all the way until it's behind the 1, because scientific notation is a number equal to or greater than 1 but less than 9 times 10 to a power. So I now have 1.0915. I can drop those zeros, times 10, and we moved it 9 places. So that would be my answer in scientific. All right, number 2, it says choose all that apply. Which equations are true? 15 to the 0 power equals 15. What is any number to the 0 power? 1. So does 1 equal 15? No. So no. All right, 8 to the 3rd times 8 to the 6th equals 8 to the 9th. Remember, when you're multiplying with the same bases, we add exponents. 3 plus 6 equals 9, so yes, that one will work. All right, C, 5 to the 2nd equals 1 over 5 to the negative 3. No. Remember, 5 to the negative 3 under a 1 merely means that it's 5 to the 3rd power. 5 to the 2nd does not equal 5 to the 3rd power. All right, D, 6 to the 5th raised to the 3rd, does it equal 6 to the 15th? When you raise a power to a power, and you can make notes on your paper. If you missed this, you need some notes. You also have it on the power bar. Raise a power to a power, you multiply the exponents. So 5 times 3 is 15, so yes. All right, then we've got a division, 3 to the 7th over 3 to the 9th. When we're dividing, we subtract our exponents. We said when stacked, you subtract. So 7 minus 9 is negative 2. So yes, that is correct. If you don't know your rules, you need to go back and look at your power bar, because there will be problems like this on the test. All right, then number 3, it says the virus that causes the flu has a width of 130 nanometers. A nanometer is this large. Write the width of the flu virus in scientific notation. All right, so to get in scientific notation, we need it with a power of 10. So I basically am multiplying 130 times this number. Now, to make it a little easier and to keep up with my numbers, I'm going to convert this one to scientific notation just to make it simple and to take care of my exponents. So if I moved it, that would be the same thing as saying times 1 times 10 to the negative 9. This is the same thing. Okay. Well, 130 times 1 is still 130. So you really have this. Okay. And it says write it in scientific notation. So this is the only part you're going to have to look. Is this number in scientific notation? No, because 130 is too large. So your decimal is here. It needs to go to the left 2 times. And we said when the decimal goes to the left, our exponent increases. So to increase -9 2 times, it will now be -7. So 1.3 times 10 to the -7. All right, next page. Okay, number 4, it says the width of a blood cell is approximately 8 micrometers, which is 8 times 10 to the -6 meters. Give your answers in scientific notation. A says, what would be the width of 7.2 times 10 to the 5th red blood cells in meters? So if one of them measures this, and you have this many of them, we need to multiply. So we're going to multiply 7.2 times 10 to the 5th times 8 times 10 to the -6. Okay? So this is our rule where when you're multiplying with the same bases, you add your exponents. So 5 plus -6 is going to give us 10 to the -1. So I have part of my solution, maybe. Then I'm going to have to multiply. So 7.2 times 8. So I've got 16, carry the 1, 576, 1 digit. So I'm looking at 57.6 times 10 to the -1. Is it in scientific notation? Because that's what the directions said. No, it's not. 57 is too large. So you need to back the decimal up 1 place to the left, and moving the decimal to the left increases your exponent. So if I increase -1, I'm at 0. And because it says in scientific notation, I'm going to leave this. This is really 10 to the 0 power. Any number to the 0 power is 1. So this is really just 5 76/100 meters. But I'm going to leave this with the 10 and the exponent because it said scientific notation. Okay. All right, then B. It says if a grain of salt is 0.5 millimeters wide, how many red blood cells could fit across 1 grain of salt? And it says, hint, 1 millimeter equals 1 times 10 to the -3 meters. All right, so then a grain of salt is only half of that. It's 0.5 millimeters. It's not a full millimeter. So I need to know what half of this is. So I'm going to do 1 times 10 to the -3. I'm going to divide it by 2. And let's just go ahead and write 2 as scientific notation. It really doesn't change much. I'm just saying times 10 to the 0 power, just so you realize that's what it would look like. All right, so 1 over 2, that's just 0.5, times 10. And when we subtract exponents, we're still going to get -3. So I have 0.5 times 10 to the -3, which is half of this. That makes sense, but I wanted you to see the math where it's coming from. Now, this is not in scientific notation. The decimal's in front of the 5. We need it behind the 5. And moving our decimal to the right decreases our exponent. So we really have that. Okay? So this is the part I have to move on with. So it's saying, okay, if the grain of salt is 0.5 millimeters wide, how many blood cells could fit across 1 grain of salt? So we're taking this measurement that we have and we're dividing it by this width that they gave us earlier. So 8 times 10 to the -6. Okay. So here we just divide. So 8 into 5, add our decimal in 0. So I'm looking at 6. So that's 48, 20, So I'm looking at 2. And I just keep adding the zeros. And 5. So I have 0.625 times 10. Now, exponents, when they're stacked, we subtract. So -4 minus -6. Think about that. -4 minus -6 is really 2. Keep change, so that's the same as having -4 plus 6. Now, my answer is still not in scientific notation. The decimal's not in the right spot. It needs to move here. And when I move the decimal to the right, my exponent decreases. So 6 25/100 times 10 to the first would be my final answer. Okay. All right, let's look at number 5. We've got some repeating decimals. Now remember, I'm reminding you, you're working ahead and then coming back to see how it was worked. You've got to try it first. All right, number 5, which is an equivalent fraction for 265,000 repeating. Now remember, when it's repeating, we put it over 9s. So we've got 265 over 999. You had 3 numbers repeating, so I need 3 9s on the bottom. All right, number 6. It says, last year a popular mobile app was downloaded 2 47/100 times 10 to the 8th times. Write the number of times the app was downloaded in standard form. So you're just taking 2.47 times 10 to the 8th. You're moving the decimal to the right 8 places. You've already got 2 places taken care of. So you just need to add 6 zeros. And then come back in and put your commas. Okay. All right, number 7. Mateo is making a wooden cube to hold his little sister's jewelry. The volume of the cube is 343 inches cubed. What is the length of one side of the jewelry box? So we got the jewelry box. We know that the volume is 343. We know that it's a cube, so that means every side measures the same. So we know for volume of a cube, we do side cubed equals the volume. Okay. So we're looking for the cubed root. We're wanting to know what cubed to make 343. So we're saying let's take the cubed root to find what that would be. That's going to give us the edge of the box. All right, so once we've got it set up, the cubed root of 343, now we didn't keep all of these numbers in our journal, but 343, you already know that 5 cubed is 125, so you have a place to start. 6 cubed, 6 times 6 times 6, whoops, would be 36 times 6. 6 times 6 is 36, carry the 3. It ends in a 6, so this isn't going to work for us. 216, but we're getting closer. So what if I did 7 times 7 times 7? That's 49 times 7. 4 times 7 is 28, plus the 6 is 343. So the length of one side is 7 inches. I just took the cubed root because it is a cube, so to find the edge, you take the cubed root. All right, next page. Number 8 says, determine if the statements are correct. Choose yes or no. The standard form of 4.15 times 10 to the 6th is 415 million. So did they take the decimal and move it 6 places? If my decimal is after the 4 and I move it 6 places, I only need 4 more zeros. So no, that's too many zeros. The standard form of 3.1 times 10 to the negative 3 is 0.0031. If it's a negative, we move the decimal to the left 3 times. So yes, I would need 2 zeros in front of the number. All right, and the standard form of 9.15 times 10 to the 11th, we're moving it 11 times to the right. We have 2 digits, so I only need 9 zeros. So yes, that is correct. All right, then number 9 says consider the expressions 5.9 times 10 to the 6th and 3.2 times 10 to the 4th. Find the difference. Difference means subtract. So which number is larger? Remember when we're talking about scientific notation, the bigger the exponent, the bigger the number. So I am looking at 5.9 times 10 to the 6th minus 3.2 times 10 to the 4th. Now, first rule when subtracting is you have to have exponents that match. So I say let's go big. So we need this to be a 6, so that means this decimal has got to move twice. So I'm really working with 0.032 times 10 to the 6th. That's what I'm really subtracting. Okay? Now, when we're subtracting decimals, you line decimals up. You add zeros as needed. You're going to have to old school and do a little borrowing. So 10 minus 2 is 8, 9 minus 3 is 6, 8 minus 0 is 8, and I bring down my 5. So I would have 5.868 times 10 to the 6th, because that is what we made our exponents. If you don't make the exponents match, you will not get the right answer. All right, B says find the product of the expression. So now we're just multiplying. We don't care that the exponents don't match. They don't have to match. Because our rule when multiplying exponents with the same base is just to add the exponents. So all I need to do is multiply 5.9 times 3.2. 2 times 9 is 18. Carry the 1. 2 times 5 is 10. Plus 1 is 11. 3 times 9 is 27. Remember, throw your 0 down. 5 times 3 is 15. Plus 2 is 17. And I have 2 places. So I'm looking at 18.88 times 10. We add exponents. Is my decimal in the right spot? No. It needs to move to the left 1 place, and moving the decimal to the left increases your exponent. So I would have 1.888 times 10 to the 11th. So be careful about that. Be sure you leave your answers in scientific notation and written correctly. All right. Number 10, I got 9.2 times 10 to the 8th is how many times the value of 2.3 times 10 to the 2nd. How many times the value? This means divide. So I'm going to put larger number on top. 10 to the 8th is larger than 10 to the 2nd. So 9.2 times 10 to the 8th over 2.3 times 10 to the 2nd. Okay. Now, we could look and go, all right, 8 minus 2 is 6. And we do have a couple of choices, but remember, when you're dividing, you've got to make sure your number is not going to affect your exponent. So we need to go ahead and divide 2.3 into 9.2, making the outside a whole number. And 23 goes into 92 4 times. So we are looking at 4 times 10 to the 6th. When stacked, you subtract. So I'm looking at B for my answer. All right, then let's look at number 11. It says Taylor multiplied 8.25 times 10 to the 4th and 0.4 times 10 to the fourth, and got 8.65 times 10 to the fourth. Explain Taylor's mistake and give the correct answer. Well, when Taylor's multiplying, if she multiplies 8.25 times 0.4, she's not going to get 8.65. But if you look at these numbers, what Taylor really did was she added. If you line up decimals, you'll get that 8.65 that Taylor got. But then she also kept her exponent, which if I was doing a sum, I would. But when multiplying, we add the exponent. So she found the sum instead of the product. All right, then when we look at number 12, it says, which numbers are irrational? Choose all that apply. So remember, we're looking for non-terminating, non-repeating decimals. The square root of 26, that's not a perfect square, so that is irrational. 5 and 87/100 repeating. Repeating is fine. That's rational. I can write it as a fraction. That would be 5 and 87/99. I'm good with that. Square root of 144. That's 12. I'm good with that. 2.16, There's a pattern, but it is not repeating, so that is irrational. And E is 2/3. A fraction is rational, so that can't be it. Never pick the fraction when they're looking for an irrational number. Okay? All right, moving on. Last page. 13 says a blockbuster movie makes about $247 million in the United States during its opening weekend. It says that same weekend another movie opens but only makes $5,200,000. We write each dollar amount in scientific. So that's easy. Here's our 247 million. We want the decimal to move all the way to behind the 2. So 2.47 times 10, and we moved it 8 times. All right, we have 5,200,000. I want the decimal to move all the way behind the 5. So I moved it 6 places. All right, B says, what is the combined revenue for the movies? And write your answer in scientific. So I'm adding 2.47 times 10 to the 8th plus 5.2 times 10 to the 6th. Now, you've got some options. They've already given you the numbers stretched out. I would be tempted to add them, just keep everything lined up and then convert your answer. But it does say scientific notation, and that's what we are learning. So I'm going to show you that route. You should still get the same answer. So this 6 is going to come up in 8. So I need to move the decimal to the left 2 times. So I'm really adding 2.47 plus 0.052. So I get 2, 12, 5, and 2 times 10, and we keep the 8. I don't have to do any converting, but if you had added, you would have had a number and you would have had to convert that. So I'm just sticking with scientific notation. All right, then C says, how much more did the blockbuster movie make? Write your answer in scientific notation. So they want to know the difference. So now I've already got them matching. So instead of adding, I'm just subtracting. So 2.47 minus the other one. So we got 8, we got 1, we got 4, we got 2, 10 to the 8th. I didn't have to go back and convert anything. I already had the numbers. I just needed the difference. And this one was the sum.
Caleb, Megan.
Okay. All right. So that's really everything you need for your test tomorrow. Hopefully you worked through it and then you looked at what I did and fixed any mistakes that you had made. Please look through your journal. Anything that is in the journal is fair game to put on the test tomorrow. Okay, you do need to study. All right, guys, these videos are going to stay up on Classroom so you can look at it. Go back. We have videos still up there on exponents, on scientific notation, on estimating square roots. It's all still there. Make the most of your resources. All right, good luck tomorrow.